Mm.
Okay, good day everyone. Today we're gonna be focusing on Unit 5. So Unit 5 is actually based on diodes. So what I'm gonna be discussing today, I just wanna look at different types of diodes, and then I also wanna look at the characteristic curve. Characteristic curve is just another way of describing the function behind a diode, but then using it like it's a graphical representation instead of using words. And then I also want to explain the basic operation of diodes. Remember, we've got Zener diodes, and then another type it's LED. So that's the main focus of today's lesson. So okay, if I were to dive deep, remember in the previous unit, the main focus was we looked at the theoretical part. We tried to look at the semiconductor theory and the semiconductor diode. That was actually based on unit 3 and 4. So in this unit, we're gonna go deeper, and then we're going to look at a typical diode and other diodes. So the main thing that we have to be familiar with is the function. How does a diode operate? Remember, the main function of a diode is to convert AC to DC. So we are going to focus on that. Okay. So if you can go through your slides on your phone or on your computer, you'll notice that there's a section that talks about the semiconductor diode. So on a textbook, if you have yourself, if you've got a textbook, which is gonna be, I'm looking at page 51, right? Just make sure that you go through that. So, okay, in the previous unit, we learned that a PN junction will allow current to flow through a diode when it's actually forward biased, and a very small amount of current when reverse biased. For all practical purposes, we can now assume a PN junction behaves as follows. It can actually operate as a mechanical switch. When it's forward biased, it's more like an open switch. And then when it's reverse biased, it acts as a mechanical switch, but it doesn't allow current to flow through. That is to say, if you gonna, I'm gonna make an analogy. So if you have yourself a tap, remember a tap controls the flow of water. So it's actually the same concept. So with a diode, if you go into, let's look at a tap. If you're going to open a tap, water is going to flow through. But if you close a tap in an anti-clockwise direction, and then water won't flow through, it's exactly the same function. So if you have yourself a diode that is actually forward biased, that simply means it's similar to a tap that's actually open. It allows water to flow through. Then we just use a different term to say it's forward biased. But when a tap is closed, then we use a different terminology to say it's reverse biased. So I hope that it's clear. That's what I was actually trying to explain by saying a diode is forward bias and reverse bias. So remember now, the issue with current is something that you cannot see. Water, yes, you can see it, but then with current, you cannot see it. So is there another way that we can actually use to describe the whole function? Of course. So you can explain everything graphically. So graphically in a way that, now this actually brings us to, I don't know if you can see, but then if you cannot see, you can just go through your slide. Let's say on I think on the textbook it's page 52. We've got ourselves VI characteristic curve. So if I were to draw this, I don't know if it's visible, but just go to your textbook or your slides. So I've got the x-axis and the y-axis. So with that, I have something like an S-curve shaped graph, something like this. I don't know if it's visible, but then if it's not visible, you can just go through your slides. So on the x-axis, I've got voltage, and then on the y-axis, I've got I. which is current, right? So first quadrant, as you can see, it's actually forward bias. Everything is just positive. You've got the positive current and you also have the positive voltage. And then on the negative side, on the third quadrant, you've got yourself a negative voltage and a negative current. Those are the two characteristics. It's not visible. Yeah, but then you can just go through your textbook, which is page 52, and also your slides that I'm going to send to you, right? So on the first quadrant, we've got forward bias characteristic, and then on the third quadrant, we've got the reverse bias characteristic curve. So this is to say now on the first quadrant, that's when now a tap is open, current is flowing through. And then on the third quadrant, the current is not flowing through. Everything is just negative, understand? So that's the basic way. This is another way of actually explaining the behavior. Remember, like we have to rely on the behavior of current. So now what I was just doing here, I was just trying to explain the behavior using the characteristic curve instead of using the words, right? So you go through the theory there that goes through forward characteristic and the reverse characteristic, right? So now you might be asking yourself, what's the fascination all about with regards to diodes? Yes, you just understood, right? You understood that a diode, its main function is to allow current in one direction, and if you reverse the polarities of your battery or your source, then it won't allow current to flow through, right? But what's the fascination? Where can we actually apply the whole thing? So now, okay, I'm going to break down the concept of rectification. So rectification, as you can see on page 53, rectification is nothing but the process of converting alternating voltage to a unidirectional voltage, meaning you're converting AC to DC. So that is to say, if you have yourself a wall outlet, what you're going to be getting from the wall outlet is AC, right? So meaning you do not want to use AC, but then you want to use DC for, let's say, a charger, or maybe let's say your computer, or maybe TV. So those components that you are using in each and every day, they rely on DC instead of AC. So now how do we convert? We convert AC to DC by the process of rectification. Rectification, you're just using diodes, right? So that's the whole thing that I'm actually trying to explain. So now there are two types of rectifier circuits. As you can see there, we have ourselves half-wave rectifier and then a full-wave rectifier. With a half-wave rectifier, you only have one diode, and we also have the input, which is a transformer. You know, we discussed on the previous units, you know the process, how the transformer operates. It can either step down or step up the voltage. I bet you can still recall. So if you are going to now plug the transformer on the wall outlet, and then from there on the secondary side, I hope you still remember I don't know if you can see, but if you cannot see, you can always go back to your notes. Remember, on the primary side of a transformer, and then this is the secondary side of the transformer. It's not clear, eh? But it's fine. Remember that the primary side, and then you have the secondary side, you've got the windings. So on the primary side, that's where now you're going to connect. You're going to take the lead and then you connect it to the wall outlet, right? So with that in mind, you're also going to have the secondary side where now you're going to connect the diode. Remember the diode? Now I'm just going to draw the symbol of a diode. So with that in mind, a diode only allows current to flow in one direction. If it's in the opposite direction, it won't allow current to flow through, right? So it's alternating current. So as it's alternating, now we can say the input